And the whole reason this article was written and that the experiment was done, according to Dr. Cyrus Raha from University of California, is that people want to learn or figure out how they can reduce the risk of Alzheimer's disease. So that was what their researchers were setting out to do. What is known so far is that there's a negative correlation between gray matter and Alzheimer's disease. So as gray matter increases, Alzheimer's disease or the risk of Alzheimer's disease decreases, or vice versa. However, they do not know if there's a correlation between exercise and gray matter. And so the researchers of this article, this was going to test that to see if there's a correlation between those two. In the article, they defined exercise as an activity like cycling, yard work, dancing, and bike riding, and then gray matter is the gray brain cells. To test or to perform their experiment, they got records of 876 adults in a heart health study that they were in. These records contain the body mass index of the patients, the MRI brain scans from 1998 and 1999, and then questionnaires that the participants filled out about exercising and activities that they do. They found that the most calories burned per week were 3,434, and the least amount of calories burned per week were 348. And they found that there was 5% more gray matter for people who were closer to burning the most calories versus the least calories. They found that the change in the gray matter was mostly in the hippocampus of the brain, which is a section of the brain that is most damaged because of Alzheimer's disease, according to this article. They also found that there was as persons increased their exercise over a five-period year, that their gray matter also increased. And then at the end of the article, they talked about what they would like to do using what they found based off this article, and they would like to see if more gray matter would reduce the risks of developing Alzheimer's disease, and if more gray matter will slow down the process of Alzheimer's disease or not, and if there's a correlation between exercise and Alzheimer's disease. So if you exercise more, will Alzheimer's disease, or your risk of it, decrease? They have the correlation between Alzheimer's disease and gray matter, and exercise and gray matter, but they don't have the two. And now we're going to critique the article based off of our 5 questions that we came up with.
Our first question is, do the results even matter, and are they relevant to the population? So, are they relevant to real life? Yes, it is, because it does show that an increase of gray matter does help reduce the risk of Alzheimer's disease. Can we apply it to the general population? No. The article title says your brain on exercise. So, first reading it, it was implied that it would be the entire populations, as in young children, young adults, and the middle-aged people. However, the article was heavily based on people in the elderly range. So we are not sure if we can apply this to the entire population. Also, we don't know that there's a correlation between increase of exercise and the increase of gray matter. And we are also not certain if we can apply this to elderly people outside of the United States. So do the results matter? Yes and no. It does show that an increase of gray matter does help decrease the possibility of getting Alzheimer's disease. However, it is not applicable to the entire population.
Another question to ask when critically evaluating research in the news is, was the sample size and composition appropriate for the study? The current article used a total of 876 participants, the average age being 78. As previously mentioned, participants were recruited from the cardiovascular health study. The participants' conditions ranged from normal cognition to Alzheimer's dementia, and there were 20 years of clinical data on the participants. In regards to the question, was the sample size and composition appropriate for this study, the answer is rather ambiguous. While there are many possible dangers of small sample sizes, 876 participants seems sufficiently large. It is important to realize that no matter what is being researched, if there is a very large number of participants, determine if 876 adults was the appropriate sample size for this study and whether or not the large sample size contributed to the effect size and power that the results displayed. Ideally, prior to beginning the study, the researchers conducted extensive statistical calculations to determine the appropriate sample size. Aside from the number of participants, it is critical to look at the composition of the participants. The sample used in the study is an important aspect of any empirical study because typically the goal is to make inferences about a population from a sample. The researchers chose an appropriate sample for the study due to the nature of their research question regarding elderly people. Because of this, it makes it possible to generalize or specify the results to the target group, which was older adults at risk for or who have Alzheimer's. Also, the nature of recruiting the participants from the other study, as opposed to random selection from the general population, was appropriate given the population of concern. The appropriate way to have recruited the participants from the other study would have been random sampling from the other study in order to be sure there was not sampling bias.
The third question that we found important when analyzing research studies is the research experimental or correlational in nature? To start looking at these questions, we first need to recognize what each type of research entails. For correlational research, it compares two variables as they naturally exist, while experimental research involves manipulation of one of the variables that would lead to a change in the second variable, which would lead to a causal relationship. And then when looking at this study, the data was collected from records of MRI brain scans for the adults to quantify the amount of gray matter, and the data for exercise was collected by a questionnaire on exercise and other types of activities, which was self-reported from the participants. Because the data was collected in these manners, there was no manipulation of either amount of exercise or the amount of gray matter. So this research was determined to be correlational. And then, was the correlational research method effective? It was effective because the data was easily collected and able to demonstrate the two variables. However, a causal relationship cannot be developed for increased exercise, leading to the likeliness of not having Alzheimer's. And experimental research would not very well be possible in this study because of the large amount of time that it would take to manipulate exercise for the participants. They would have to be very much observed and to make sure that they stuck with the exercise schedules, and also there would be ethical issues that would potentially lead to the participants in the low exercise group having a higher susceptibility for Alzheimer's. So the correlational research overall was most effective for this study.
The fourth question we asked was, how did the researchers define their variables using operational definitions? The first variable is exercise, and researchers use various types of exercise. It could be what is commonly known as exercise, aerobic activity, or even daily activities such as raking leaves or dancing. And they calculated this by measuring how many calories they burned within that week. They focused on physical aerobic activities because they know that this leads to a cerebral blood flow and strengthens the neuron connections in the brain. They also looked at fMRIs to measure the amount of gray matter in the participants. So they focused on the hippocampus because they know that that is where it is damaged due to Alzheimer's disease. And although they knew that, although they now have a correlation between exercise and gray matter, they are now hoping to link this gray matter to developing a lower risk in developing Alzheimer's, or at least getting a slower progression of Alzheimer's disease. They are currently going through surveys to see if they can predict who is more likely to get Alzheimer's based on this gray matter and exercise information.
And then last but not least, question is in regards to the results, are they understandable to the reader, and do they make any claims for which there is insignificant evidence? So we're going to look into it in two parts. The first part is, are they results understandable to the reader, and we exercise increases gray matter. They don't just state there's a positive correlation. They explain what the positive correlation is for anyone who doesn't know the definition of correlation relationships. Also, they said that there was a 5% difference or more gray matter, so they told you what the difference was. And then do they, the results, or the researchers, make any claims for which there is insignificant evidence? I believe they have all the claims have evidence. However, the evidence that they do have for some of the claims is weak. Like they don't tell you where they got the research, the records from. They could have been like, you could find them here so that other people could double check from what they concluded. They don't have any, they don't compare or show any MRI scans. They could have compared those so that all their audience could understand what they thought was a lot versus a little. And they don't have any p-values, f-values, or standard deviations.
So, through our conclusion, we have decided that the research came up with good results, but it isn't applicable to the entire population. They had a large sample size of an older group of people. They did conduct a longitudinal study. The research was correlational because there was no manipulation of the exercise. The research used fMRI scans to detect gray matter, and they considered exercise as any activity that helped burn calories. There was evidence to support claims, but the evidence was very weak. So we believe that the article was a good article, perhaps not the best, but it did have results that we could find evidence